Hello everybody and welcome to a special edition of seemath Run. Today we're going to look at the connection between geometry and statistics. First thing I'm going to do is I'm in the geometry window, which is menu H. I've set up a circle, a line segment. The circle has a center of E, radius of F, and is on line segment DE. I've changed the colors of those two so you can see them better. To set up an animation, I've selected point F, line segment DE. I'll say add animation. That animation already exists, so that's good to go. I'll exit all this stuff out of here so I don't have anything selected, won't have anything cluttered. I will go ahead and tell the animation to go once. Going from large, shrinking down. What I'm going to do is I'm going to collect information on that circle, circumference and radius. We use those two bits of information to generate pi, or to show you a connection of how pi is generated from those two values. My animation is now done. I'm going to select the circle. Selected circle. I want to go to F6. Add table. There's my radius. Exit. With my circle still selected, I'll go to variables. Allow me to change what I'm looking at. I want circumference. I'll go to F6, add to table. There's my information. Now I've gone ahead and stored this information in list number 2 for circumference. That's already done. Just to show you what I did, I went over to radius, store that in list number 1. I already did that. Show you. I'll go into menu. Statistics, which is 2. I've got the radius, circumference. I calculated the diameter. The way I calculated the diameter is I typed in the word diameter. Up at the top of the list, I just said 2 times list 1. Calculates my diameter. I went ahead and turned on the color link if you remember how to do that from one of the earlier videos. If not, I'll show you that at a later video. What I want to do is I'm going to graph this. I'm going to graph list 3 with list 2. I set up this graph. My X list is my diameters. My Y list is my circumference. See if you remember what the relationship is between diameter and circumference. So I'll exit that. I'll go ahead and hit graph. There's my color linked graph. So those colors match with the colors in the list. Looks like a regression to me, so I'm going to calculate a linear regression, ax plus b. Lo and behold, what's the one number we recognize there? Looks like the slope is pi. Remember what I said earlier. I'm going to go ahead and copy this into number 1 here, y1. Then I'll go ahead and draw it. So remember what I was telling you about, what do you remember about the value of pi? The value of pi is the ratio of the circumference to the diameter of the circle. So circumference divided by a diameter, change in y, circumference, over change in x, diameter, and there you have it. Quick way to show that pi is in fact the circumference divided by the diameter. We did that via linear regression. There you have it. Y-intercept of 0, which means it's right on there. R and R squared, pretty close to 1.9999. The reason there, again, is pi is an irrational number, and I'm sure that this has a little trouble calculating the exact value of pi, which is a good thing. It's also Einstein's birthday, so happy birthday, Mr. Einstein. I believe he would have been 114, right around there. So this is a special edition of seemath Run, Pi Day edition. See you on Wednesday.